Okay, so we're gonna talk about graphing derivatives. And so let's say you've got a function, and first, before we actually get to the graphing aspect, let's just talk a little bit about the different characteristics of the derivative in different situations. So first off, let's talk about the derivative right here and the maximums and the minimum points. Notice that if I draw a tangent line right here, the tangent line would be horizontal. And so what that means is that the derivative at that point would equal to 0. Okay, now notice that at all these points, so throughout from here all the way to this point, notice that the function is increasing. Now, what that means is, in terms of the derivative at least, if you draw a tangent line at any point right here along this line where it's increasing, if you draw a tangent line, those lines are going to be have a positive slope, which, if it has a positive slope, that means that the derivative would have to be positive, because the derivative at a point is the slope of the tangent line. So since the slope of the tangent line is always positive here, that means the derivative is going to be positive. Now, for this section right here, where the function is decreasing, the opposite is true, because right here, notice that the function is decreasing, and what that's going to tell you is that then the derivative is going to have to be negative, because notice if you draw a tangent line at any one of these points, it's going to have a negative slope. And so the same thing is going to be true over here. It's going to have a positive slope. And so that way we can tell what the sign of the derivative is going to be. Okay, so let's do a simple example. Let's say I want to find, if this is my function, let's say I want to graph the derivative of it. Okay, so let's start off using our 3 main points that we just discovered. We know that the derivative at around this point would have to equal to 0, so I know it would have to cross right there. And since at this point my derivative is also equal to 0, then it would have to cross 0 on the derivative right there. So again, what I'm graphing here is the derivative of this function. Now, this guy right here is, so we just said that it's increasing, which means that the derivative would have to be positive. And since I know that it has to go over here, then if it's positive, then it's going to be coming down in some way. Now again, this is a rough sketch, of course. And so I know that it's going to hit here, and so that's it for that part. So see, notice it's positive. Now this doesn't say anything about whether the derivative is increasing or decreasing. It's just saying that it's positive. So because it's positive, that means it has to be above the x-axis. And since I already knew that it has to hit right here, then that's why I brought it down right there. Now notice that right here, since it's decreasing, the function is, that means that the derivative has to be negative right there. And then it has to hit again right here. So I'm going to assume that what that means is that if it's going to be negative and it has to hit right there, then it has to go something like this. Okay. And then the last one is, again, the derivative is positive after that. And so it would make sense that it would just continue on this path and be positive. Now I made quite a few assumptions here, but that's just because we're just getting started. A few things to note. Notice that this guy, the original function, has 2 humps, and the derivative has 1 hump. Now, can you guys think about why that might be? Okay, well, I'm going to leave that as a homework. You guys think about that. Why that is. And another thing is, well, how do we know that, for example, right here, this guy comes down and then goes up right there? I mean, how can it maybe go, something like this and then come up? There's a lot of questions there. So, to get a better idea, what we want to do also is not only look at the function, whether it's increasing or decreasing, but also look at what's happening to the derivative. I mean, is the derivative, we know it's positive here and negative here, but how can we tell if it's increasing or decreasing? Okay, so to do that, we have to look at the derivative of the derivative. Or, in other words, also called the second derivative. Okay, now if you take a look at, so basically what we're doing is we're going to pretend like this guy doesn't even exist right now. And we're just looking at this guy, and we want to find the derivative of this guy. So we're going to do exactly the same thing we did here, but we're going to put it into this guy, and this is going to be called the second derivative, or f double prime. Okay, so well, we know, let's do the same analysis. Because this guy is decreasing from here to here, well, actually, first, before we do that, this guy, the tangent line is 0, so that means at this point, this guy would have to cross right there on its derivative, or the second derivative. Okay, now, because it's decreasing here, then that means that the second derivative, the derivative of the first derivative, is going to have to be negative. And then over here, because it's increasing, then that means that the second derivative is going to have to be positive. Okay, so if it's negative over here and positive over here, well, then it stands to reason that it would look something like this. Okay, now, what do you notice? Okay, so I want you guys to take a look at something. So you've got this point right here. If you compare the spots where the second derivative is positive to the original function, what do you notice? Right there. So this is the corresponding spot where the second derivative is positive, and it corresponds with this part of the original graph. Interesting. Okay, now notice right here you've got, these are the spots where the second derivative is negative. And let's take a look. This is this guy right here. What's the difference between this green and this yellow? Well, if you said that right here, this is concave down, and that you said that this guy right here is concave up, then you were exactly correct. Exactly correct. Okay, so let's summarize. So all this, I mean, this is a lot of information that I just gave you. A lot of information. So let's try to summarize this into into something that we can handle. We're going to make a little table. Okay, so the question is, what's the connection between the sign? So these are the two things. The sign, I'm looking at the sign, and I'm looking at whether it's increasing or decreasing. Okay, and what's the connection between them? Okay, so the first thing is, if my function is positive, what does that tell you about the first derivative and the second derivative? Okay, I'm waiting for your answer. If you said nothing, you would be right. And nothing. Because the sign of the function, either positive or negative, tells you absolutely nothing about the derivative or the second derivative. Now, if the original function is increasing, however, that's right here. Remember, what that tells you is that the first derivative is going to be positive, because we talked about that earlier. That's what that tells you. And if the original function is decreasing, then that means that the derivative is going to be negative. So that's the connection between those two. Now, let me erase a little bit more. I'm going to need a little bit more room here. Okay, now, what does that tell you about the second derivative? Well, if the original function is increasing or decreasing, we know the derivative is positive or negative, but notice that doesn't tell you anything about the second derivative. Nothing. Nothing. So you can't say anything about the second derivative only by looking at whether the function is increasing or decreasing, or by looking whether the derivative is positive or negative. Remember, what we looked at when we were doing this is we were looking at whether the derivative was decreasing or increasing. And that's what told us what was going on with the second derivative. So if the derivative, the first derivative, was increasing, remember, we said that the second derivative was going to be positive. And if the first derivative is decreasing, then that told us that the second derivative was going to be negative. Exactly the same connection that you have from the function to the derivative, you have from the first derivative to the second derivative. And of course that makes sense. You know, it's just another function. So there should be that connection. Now, the big one, this is the big one. This is why we spent all this time on this. Can you jump from the second derivative at all to the original function? And the answer is absolutely yes. Yes, you can. Notice that in the area where the second derivative is positive, that's where the original function was concave up. And in the area where the second derivative was negative, the original function was concave down. And so that's the connection. And this is going to help us not only right now to graph the derivatives, but also later on when we apply derivatives. Okay, so let's do an example that's a little more challenging. We want to find the graph, a rough sketch of the first derivative and the second derivative. So assuming this is the original function, this guy right here, find the first derivative and the second derivative. So we're going to start off with the first derivative. Let me choose a different color there. How about light blue? No. How about a yellow? Okay. Now, so we're going to start off. This one's quite a bit more challenging because, well, we've got a vertical asymptote here. We've also got a horizontal asymptote right there. But let's start off with the basics. So I know that my derivative has to equal to 0 in these spots right here. So if I go straight down, I know that my derivative has to go right there and right there. Now, I know that, so let's go through, and basically I'm just going to use this table, and I'm going to use what I know about this to write down some information. So I know that from here to here it's increasing, and from here to here it's also increasing, and from here to here it's also increasing. So what I get from that is that the derivative, because it's increasing in that area, the derivative is going to be positive. Right here the derivative is going to be positive, and right here the derivative is going to be positive as well. Okay, and then in this area where it's decreasing, right here, the derivative is going to be negative, right? Because the function is decreasing, so that means that the derivative is going to have to be negative there. Okay, now let's look at the second layer, the concavity. So notice that from here to here, sorry, here to about here, let me do that over again. Okay, from here to somewhere around here, the function is concave down, which means that from here to about right there, the derivative, because it's concave down, that means the first derivative is going to have to be decreasing. Okay, and then here, this guy is also concave down, so that means that the derivative is going to have to be decreasing there as well. Okay, and then right here, since it's concave up, then that means that the derivative is going to have to be increasing. Okay, now another thing to notice is that we want to also take note, because we have asymptotes, we have to take a look at not only that it's increasing, but notice that the derivative, the slope of this tangent line, notice how it's getting steeper and steeper and steeper. The slope, or the derivative, is going to infinity right here as well. So if I have a vertical asymptote right here and I take the derivative of that, I'm going to also have a vertical asymptote on the derivative, because the slope of the tangent line is also going to infinity. So that makes sense. And another thing to notice is that as this guy goes towards 0, this horizontal asymptote, the slopes of the tangent line are getting horizontal, which means that over here, the derivative is also going towards 0. The slope is going towards 0. So that's just something to keep in mind. Now, with all of that, we can make a pretty good picture. Here it's going to be positive decreasing, right? So positive decreasing. And then here it's going to become negative, but still decreasing, until right about here, when this guy tells me now I'm going to start increasing. Still negative though. And then right here it becomes positive, and I know that I'm going towards infinity as well. Okay, now what this guy tells me is that it's going to be positive decreasing, and I know that it's going to be going towards 0. So that means that it has to be coming down right here towards 0, positive but decreasing. And that's it. That's the first derivative. And then to find the second derivative, you don't have to do anything super fancy. What you want to do is you want to completely ignore this guy right here. So we ignore this one when we're trying to find the second derivative. All we're doing is we're looking at the first derivative and graphing off of that. So this one, we're not even looking at that one right now. We're only looking at the first derivative and pretending as if we're moving from this step to this step. We're going to do exactly the same, moving from this step to this step. Okay, so let's do that. So first things first, exactly the same. Right here where the derivative is 0, I'm going to cross the x-axis. Let's do this first. So here it's decreasing, which means that the derivative is going to be, the second derivative, second derivative, or the derivative of this guy, is going to be negative. Here it's increasing. And notice exactly the same thing. We're also going to have the vertical asymptote. And we're also going to have the horizontal asymptote. Because again, the slopes of the tangent lines are going towards 0 here. Slopes of the tangent lines are going towards infinity. So the same asymptotes. And so here it's negative, here it's increasing, which means that the second derivative is going to be positive. And over here it's decreasing, which means that the second derivative is going to be negative. Okay, now let's take a look at the concavity and see what that tells us. The concavity tells us that, so right here it's concave up, which means that throughout here the second derivative is going to be increasing. Okay, so that makes sense. You know, again, from the same thing from this one. So it's like you're looking at the concavity of the first derivative tells you whether its derivative is increasing or decreasing. It's exactly the same connection that we have right here. You're just going from the first derivative to the second derivative, as opposed to the, between the function and the derivative. Okay, so, and then over here, I know that the, because it's concave up right here, then that means that this guy is also going to be increasing. Okay, so then once I put those two together, I can draw a pretty good picture, because I know that it's going to be negative increasing and then positive increasing, and it's going towards this guy. So something like this. And here I know that it's negative increasing, which means that it has to be coming up like that. And that's it.